Hello, welcome back. Now we have to take one final look at one short little thing. What it is it's figuring out derivatives through estimation. What is the slope at a certain point? If I give you a table, if I give you a graph, and you're just going to use some sort of estimation skills to try to figure it out. We're also going to use the idea of the average rate of change. And remember, average rate of change, again, is the slope of a line through two different points. So what I'd like to do is I'm going to share my screen with you, and then I would like you to pause the video and copy down the table and the thing that's underneath it. So once I share my screen, pause this video and copy this down. Okay, so this is the table and the three things I would like you to find. Okay, so pause the video now and copy down the table. Now, if you notice here, it says we're going to estimate derivatives using tables and graphs. So I'm giving you a table here, and you notice that we have some x values, and they're all even numbers, and we have some y values, and they're all some sort of decimals. So the first thing I want you to notice is all three of these problems, I use all three of the representations for derivative. Okay, we can say f prime of 7. So let's figure out what f prime of 7 is. Well, notice in the table that there is no 7. But we do know two numbers fairly close to 7 on either side of them. We know 6 and 6.8, so we know that point. And we also know 8 and 7.1. So if you are estimating a derivative, that's when you use the average rate of change formula. So we're just going to do 7.1 minus 6.8 over 8 minus 6. So we get, what is that? 0.3 over 2. So if we were to do this as a decimal, 0.3 over 2, 0.3 divided by 2 is 0.15. So f prime at 7 is about 0.15. Notice I use the wavy little equal signs there. Wavy little equal signs means that it's an estimation. It's kind of close to that. So we're not going to say it's exactly 1.5, but it's about 1.5. Okay? Now, this second one, it's also another form of derivative. But what this means is this is the derivative at x equals 3. Okay? So again, looking at the graph or at the table, you'll notice that there is no value at 3. So again, we have to use 2 points on either side of that thing. That's as close to 3 as we can get. So we have to use 2 and 3.1. And we also have to use 4 and 5.7. Okay? Again, the average rate of change formula really comes into play here, because we can't use the limit definition of a derivative because we have no value to even kind of go towards, and we can't, if it's a table of values, so the only thing we can do is just figure out the average rate of change. So let's do 5.7 minus 3.1 all over 4 minus 2. So 5.7 minus 3.1 is 2.6 over 2. And when we divide that, we end up with the derivative of x at x equals 3 is 1.3. Okay? So this is just another way of saying or saying what the derivative is. Okay, so notice the notation, but it all means find the derivative at that value. So what is the slope at that exact point? So the final thing is we have this last one, and notice It's the final notation of what we would say a derivative is. This is y prime, okay? So what is the value of y prime at x equals 5? So again, notice that we have nothing at y prime, or at 5, so we have to pick a point on one side and a point on the other. So we'll use the 2 points 4 and 5.7 and 6 and 6.8. And you're going to need to go through and do the average rate of change again. So it'll be 6.8 minus 5.7 over 6 minus 4. So 6.8 minus 5.7 is 1.1 over 2, which ends up being 0.65. I think my math is all 0.55. So y prime is equal to 0.55 at x, or at x equals 5. Okay? But notice, everything is based off of the x value. We're always going back to what is the slope at x equals something. Okay? What is the value at x equals something? So we're always going back to those x values. That's our key thing in this whole process. So let's do one more thing. Okay? That's what we do if we have a table. So the next thing I'd like you to do is I would like you to copy down this graph. So pause your video and take a moment to copy down the graph with the 3 very different lines on it. So pause your video now and make a picture of the graph that looks something like mine. Okay, so here we go. If we take a look at this, you will notice that we have y prime at 5, okay? So, or f prime at 5, sorry. So we have f prime at 5. So what that means is we want to find the derivative at 5. The derivative is the slope of the line at 5. So the first thing you have to do is you do need to draw in a tangent line. So notice I drew in a tangent line at this point. It's a line that goes through and it just touches the graph at that point, and that point only. So you're always going to try to just be skimming the edge of the graph at 5. Now, in order to estimate a derivative using a graph, what we need is we need to kind of look and see, where does this line kind of cross somewhere so we can use another point to calculate the value. So on this graph, of course, we don't have a piece of graph paper, but if we were on a piece of graph paper, we could follow the line either this way or this way and find a value or a point that we could use to calculate the slope. So let's say we actually find out that this is 8 and 6, okay? So we look up the line and we can find the 0.86. So now we use the average rate of change to find the slope of the line for here, okay? So we're going to use 8 and 6, so we'll use 6 minus 3, subtract the y's, over 8 minus 5. So 6 minus 3 is 3, 8 minus 5 is 3, so the value of f prime of 5, oops, I'm using the wrong color, the value of f prime at 5, so the derivative at 5, is about 1. And notice, I should use the little equal signs, because, or the little wavy equal signs, because it is an estimate, okay? So it is about 1. Now, take a look at the next one. I'm still asking you the same thing. I am asking you, what is the derivative of the graph at x equals 1? So the derivative of the graph at x equals 1. So that one is the pink line. So notice my pink line skirts across that 1 there, and I have this line that kind of goes this way. And notice it's fairly flat, okay? But I do know that the point here is at 1 and 2.5. So I do need to try to find some other value or some other point where I can then use the average rate of change to estimate what this one is. So I'm just going to kind of pretend that right here is that other point. So as I go over, I'm going to say this one is at 3 and let's say 2.7. Okay, so I could estimate that that value is 3 and 2.7. So what do? I use those 2 points to find the slope of this line. So it would be 2.7 minus 2.5 all over 3 minus 1. Okay, so I'm using these 2 points to find the average rate of change. So this will end up being 0.2 over 1. So the derivative of this function at x equals 1 is equal to 0.2. Oh, again, I should use the little wavy equal signs because it's not the exact value. It's just an estimated value. Okay? So if you kind of see how this works, it literally is with a graph, you're going to find points. So first of all, you have to draw in that tangent line. So notice on the last and final one, y prime at x equals 12. So here's the point x equals 12. It's at 12, 3. And what I did is I drew a tangent line that just touches that point, and it goes straight through there. So you're always going to be using a ruler or a straight edge to draw a tangent line, but you just want to touch that graph at that point and then draw the line in. Now, of course, you're going to have to then find some other values. So if you actually had a graph, you would look here and you go, oh, right up here, it looks like it touches at 10, a y value of 8. Okay, so it touches at 10, 8 there. So we're going to use this point and this point 12, 3, and we are going to estimate the slope of the line at that point. So if I use the first one, let's take 8 minus 3. So I'm going to do 8 minus 3 over 10 minus 12. Okay, so you subtract the y's and you subtract the x's, so we get 5 over negative 2. So in this case, the derivative at that point, y prime, is equal to negative 2.5. Okay, and that is the slope of the line at that point. So this is how we estimate derivatives. Okay, so you can either get a table of values, and you have to estimate by picking values on either side of the x value, or you might get a graph and they might ask you to estimate the values. So you need to draw in a tangent line that just skirts on that point, and then you need to find some other point that is on that line to use to estimate the slope by using the average rate of change. So I hope this helps you. I hope it'll help you get through the problems, and good luck with your assignment. So good luck.